Good afternoon. My name is Jason Burton and I'm with the U.S. Geological Survey Office of Communication. I'm here in the South Atlantic Water Science Center in Norcross, Georgia, and this afternoon I'm going to be speaking with USGS hydrologist Brian McCallum. Brian is one of the storm tide coordinators for the USGS in our efforts for Hurricane Matthew. Good afternoon, Brian.
Hey Jason, how are you?
I'm doing great. To start off for our viewers, can you give us a little background information about Hurricane Matthew?
Yeah, Hurricane Matthew is a monster storm. If you've been following it on the media, it's caused a lot of devastation in Haiti, killed hundreds and hundreds of people there. And now it's coming up the Atlantic coastline of the United States and posing a severe threat to our citizens.
Okay. Could you provide our viewers with some information about what the USGS's role is when it comes to dealing with major hurricanes like Matthew?
Sure. Well, as a mission for our agency, we are tasked to keep track of the Earth's resources. And one of those things is severe events such as floods, droughts, and now even hurricanes. And so what we are trying to do here is keep track by putting a lot of sensors out in front of the storm of what the surge is going to be so we can document the extent and the magnitude of this storm as it hits the Atlantic coastline. We've been doing this for a number of years now. Immediately after Hurricane Katrina, we came up with an idea of using regular sensors that we use for other purposes and reuse them in a way to monitor the surge along the coastlines. We've been doing this for all the major storms that have affected the United States, including Hurricane Irene and Hurricane Sandy.
Okay. We have a question from Bridget, and she's asking if we're in Reston.
Currently, no. I'm in Norcross, Georgia, which is just outside of Atlanta.
Okay. So can you talk a little bit about some of the technology that the USGS is using to monitor and capture data from Hurricane Matthew's impacts?
Sure. This picture here I'd like to show is one of our hydrologic technicians that recently put out one of our sensors along the Florida coastline. As you can see, the housing here is strapped to the piling. We try to put it in locations where it's going to measure the storm surge, but also will hopefully be there when the storm passes by. I have an example of one of these storm tide sensors here in my hand. This sensor logs the data, does not transmit it, but it just logs it. The water comes into these holes here and it measures the pressure or the height of the water on this sensor. And we protect it in a housing like this. This is a typical housing made of aluminum. We hang the sensor, the storm tide sensor, from this little eyelet here and screw the lid onto it. And the water enters through the bottom of the pipe, and we strap it in a vertical fashion like this. We can either bolt it to a concrete head wall or strap it to, say, a utility pole. And the idea is we come in and we survey to this top of the sensor here, the housing, and we can then determine what the elevation of the sensor was.
Okay. And my understanding is you like to strap these to relatively sturdy items so that they're likely to be there when you go back?
Yeah. The data is invaluable for many of our different federal agencies and users. So we'd like to make sure we get the data when we go back to the place. Typically anything like a utility pole or bridge pier or something like that, something that we hope will withstand the surge effect.
Okay. And I understand there's another type of sensor called a rapid deployment gauge. Can you talk a little bit about that?
Yeah, exactly. This next picture here is one of our rapid deployment gauges being deployed along the Georgia coast. It's typically hung off the side of a bridge, and the water level sensor here will measure the changing of the water surface as the surge comes in.
Okay, and then we also have a model here for you to demonstrate as well.
Yeah. Typically we make these out of an aluminum box, and these braces are attached to the bridge or the pier or something that is relatively high up, because this is a very expensive device. and so we don't want this one to get damaged if at all possible. But the idea is this water level sensor sticks out of the bottom of the box, and all the electronics are housed and protected in there. And then this antenna shoots the data to the satellite on an hourly basis so that we get real-time data feeds during the storm.
Okay.
This sensor on the top here is an all-weather sensor. It's no moving parts. It has acoustics to measure wind speed and direction, as well as air temperature, precipitation, and barometric pressure. And so then inside, this is the water level sensor that is shooting out of the bottom of the box, and we have a data logger and a transmitter that gets the data, keeps it there, and then transmits it through the satellite. This entire thing is self-contained. It runs on a gel cell battery and powered by solar panel. And one last important thing is we have our visual identity and who to contact in case you ever run across one of these, so that people know how to get in touch with us if they find one.
Okay. So you've talked now about the technology that the USGS uses to capture this data, but can you tell me and the viewers a little bit about why is that data important and what is it used for?
Well, there's many different reasons or uses for the data. The non-transmitted data is used for after-storm analysis and improvements of hurricane surge forecasts. FEMA uses the information to create maps of impacts so that they can better target their resources and response during the recovery efforts. The real-time data from the rapid deployment gauges is critical during the storm event itself because people, the National Hurricane Center, the National Weather Service, all uses this information to improve their flood forecasts and warnings. And then, of course, the emergency management agencies are using that information to get people out of the way.
Okay.
And one additional thing, the data after the storm is used by scientists from the USGS and other federal agencies to improve coastal geology change, modeling, and other impacts from these hurricanes that affect the United States.
Okay. At this point, I just want to remind our viewers that Brian will be taking questions, so if you guys have anything that you want to ask or any clarifications you would like, please feel free to type it in the comment box and we'll be sure to get that question to Brian. At this point, Brian, we have talked about kind of what the USGS is doing. Now we've talked about how we're doing it with our technology. Can you talk a little bit and explain where the USGS is currently deployed and where this all this sensors are being deployed?
Sure. This next slide here gives you a current snapshot of where the hurricane is currently positioned. You can see the eye of the storm. This image is from the National Weather Service radar, and so currently it's off the coast of Florida and it's heading along its projected path along the coastline of the United States. You can see the outer bands of the hurricane are already impacting Georgia, South Carolina, and even up into the Carolinas a bit. So as the storm progresses, this is the forecasted track from the National Hurricane Center, and you can see it's projected to go right along the coastline and then actually loop around back onto itself, which is kind of unique. We haven't seen that in a long, long time. This is again from the National Hurricane Center. And so a new product that the National Hurricane Center came out with just this year is actually a storm surge forecast. The coloration that you see along this coastline, and this is Jacksonville all the way up to Savannah, determines or is an estimate of what they expect the storm surge to be. And you can see the yellows, which are greater than 3 feet, and the oranges are greater than 6 feet above ground surface. So the impacts are going to be significant, especially along the Georgia coast. And that's because the storm and the winds are pushing the water into the Georgia coast, and it's just going to back up all along the Georgia, South Carolina coast from Jacksonville probably all the way up into Charleston and beyond. And so to respond to this, we have deployed over 300 sensors all the way from Miami up into Virginia. Many of these are the storm tide sensors that are non-transmitting, but the green triangles you see are the real-time gauges. And we had to do this because we have to get out in front of the storm before it gets close to landfall. So the forecasts were still changing over time, and so we had to be prepared. And so we went from Miami all the way up into Virginia, and that's why it's such a large deployment for this storm, because the forecast has been very uncertain as it's gone through time. To zoom in a bit, the black triangles on the screen here are our long-term fixed real-time stream gauges. We operate those day in and day out, but the red dots are storm tide sensors and our rapid deployment gauges. Those are our temporary sensors that we put out just for Matthew, and it's to kind of fill in the gaps in between our existing network. And so we're going to be collecting data at all these locations, and as soon as the storm passes by, we're going to be back out there. The USGS crews will be collecting the data and getting it uploaded to our online flood viewer.
Okay. Now, one thing you mentioned that I want you to talk about just a little bit is you mentioned that this is a relatively large deployment. Can you talk a little bit about how large this is in scale to previous hurricanes such as Sandy?
This is actually the largest in USGS history. We've deployed more than 300 sensors across the Atlantic seaboard. Sandy was the next largest in terms of the overall magnitude of the effort because of the impacted area around the New York City area and beyond. Our actual largest deployment was Hurricane Irene, which was in a similar area along the North Carolina coast. But by far, this is now the largest deployment.
Okay. So you kind of hit on this a little bit, but can you talk about what is the next step? You know, all these sensors have been deployed. You know, the crews are now safe, waiting for Hurricane Matthew to pass. But what will the USGS's role be once Hurricane Matthew has dissipated?
Well, right now our crews have fallen back into a safe location to ride out the storm. But immediately after the storm passes, they will be back out into the field to collect the data from these sensors and transmit it up to our office so that we can process it and get it posted on the flood event viewer. Additionally, if the event and the impacts are significant enough, we may be doing high water marks along the coastline and surveying all these elevations in so that the information can be fed to FEMA for their response and recovery maps.
Okay. So if any of our viewers have more questions, or if they have any more information they want to get, what's the best source they can go to get that information?
Well, I do want to highlight one other thing before we get to that, Jason. One of the things that is not thought of many times during hurricanes is the actual inland flooding that's caused from hurricanes. This graphic from the National Weather Service is showing potential flood threats because of the previous rains that have been occurring in North Carolina. The ground is very wet. And if we get a lot of rainfall from Matthew, which is currently forecast, many of these locations in purple, which designate major flooding, could go into serious riverine flooding. And so our next task after the storm passes as well will be to measure these locations to ensure that the Weather Service is getting accurate information for their riverine flow forecasts. Additionally, we will be processing this information, making sure that the information is used for future models for coastal change, for beach erosion and things like that, and also be used for landslide monitoring along the Appalachian Mountains. But to get more information, all you need to do is go to www.usgs.gov, and this is our main web page, and you can get all the information that USGS is currently doing.
Awesome. Well, thank you very much, Brian.